Dr. R.K. Radha, Assistant Professor, Department of Statistics, Presidency College, Chennai. She has done her PhD in statistics on a novel approach for prior selection in Bayesian modeling. She has 27 years of teaching experience, has guided 4 MPhil students, published 5 articles in national and international journals, has attended 10 conferences in India. She had given training for staff at Tamil Nadu State Statistical Training Institute, Department of Economics and Statistics.
Welcome to UGC lecture series on statistical inferences. Today's class we are going to discuss about the parametric test. We are going to discuss about parametric test and non-parametric test procedure, and we are trying to differentiate between these two. Then we are going to discuss about the non-parametric test procedures and how to perform the hypothesis test using the non-parametric procedures. So, here let us differentiate between the parametric test procedures and non-parametric test procedures. So, parametric test procedures involve the population parameters, say for example mean, median or whatever it is, having stringent assumptions, that is normality conditions will be the main backbone for a parametric test. So, certain example for parametric test we have done is z-test, t-test, chi-square test and f-test. Coming to the non-parametric test procedure, it does not involve any population parameters, that is it does not depend upon the probability distributions, no independence condition. Next, data measured on any scale, namely it can be either ratio or interval or ordinal or nominal. Example for a non-parametric test, simplest example is the sign test. Now, what are the advantages of non-parametric test? It is used with all scales, easier to compute, less number of assumptions to be made, it does not involve any population parameters, and the results may be exact as the parametric procedures. What are the disadvantages of non-parametric test? Many waste information, whereas parametric model more efficient if data permit. Some of the information we will not be using, whereas in parametric test those we will be using it out. It is difficult to compute manually if the samples are very large. Tables are not widely available. Non-parametric tests are designed to test statistically only and not for estimating the parameters. So, let us see what are the popular non-parametric tests which we are going to discuss. Sign test, Wald-Wolf's run test, median test, Mann-Whitney-Wilcoxon U test. So, to start with, I am going to discuss about the sign test. So, let us see what the sign test says. The sign test is a non-parametric test that is used to test whether or not two groups are equally sized. Secondly, it is used when dependent samples are ordered in pairs, where the bivariate random variables are mutually independent. Third, it is based on the direction of the plus and minus sign of the observation and not on the numerical magnitude. It is also called a binomial sign test with probability value is equal to 0.5. You know that for a binomial distribution, probability of success and probability of failures is equal to half, hence p is equal to 0.5. The sign test is considered a weaker test because it tests the pair value below or above the median and it does not measure the pair difference. Here instead of median you can also compare with the mean or any other quantile measures. What are the assumptions of the sign test? First, data distribution. Sign test is a non-parametric, that is distribution free test. So, we do not assume that the data is normally distributed. Next, you can consider two sets of samples and the population for these sample also may differ. Third, dependence upon the sample. If it is dependent, sample should be paired or matched or also you can consider it as before and after sample. What are the types of the sign test available? There are two types, namely one sample test and two sample test. One sample we set the hypothesis so that the plus and the minus signs are the values of the random variables having equal size. Paired sample. This test is also called an alternative to the paired sample t test. That is, in paired sample test we take the difference, then we try to do the test procedure. Here this test is used as a plus and minus sign in paired sample test or in before and after study. In this test, null hypothesis is set up so that the sign of plus and minus are of equal size, or the population means are equal to the sample means. Now, what is the procedure to go for the sign test? First, calculate the plus and minus sign for a given distribution. Put a plus sign for a value greater than the mean value and put a minus sign for a less than the mean value. Instead of mean, you can take also even median value. Put 0 as the value is equal to the mean value. Pairs with 0 as the mean value are considered as ties. Denote total number of signs by n. That is, while doing it so, you ignore the sign, 0 sign. Suppose if there are 10 observations, of which 2 observation has the same mean value, then 8 will be your number of signs, and the number of less frequent signs by S. Compare the value of S with the critical value of K. If the value of S is greater, the null hypothesis is accepted. If the value of S is less than the critical value, the null hypothesis is rejected. In the case of large sample, S is compared with the Z value. So, let us see how to go about to do the problem under sign test. Here I have taken for one sample sign test. Let us go through the problem. There is a recharging time in hours of a battery powered hedge trimmer was studied. The sample consists of 11 times. So, the observations are given from 1.5, 2.2, 0.9, 1.3, 2.0, 1.6, 1.8, 1.5, 2.0, 1.2 and 1.7. The distribution of recharging time is unknown. If the distribution is known, then it becomes a parametric procedure. We are talking about non-parametric procedure, except that we know that it is continuous. At the 5% level, is there evidence that the median recharging time is 1.8 hours? So, we want to check whether the median recharging time is 1.8 hours. So, let us go for the solution. First, step 1, make the null hypothesis about the true median. That is, here you have been given that recharging time is 1.8 hours. Therefore, your H0 is such that eta equal to 1.8 hours, H1 is going to be eta not equal to 1.8 hours. So, step 2 is, if null hypothesis is true, S should have binomial distribution with success of probability P is equal to 0.5. That is a procedure to verify. Step 3, let S be the number of values which is greater than median. That is, from the given observation we have to check how many values which are greater than 1.8. Here each sampled item is independent. So, one of the realized sample element is exactly 1.8 hours, it is left out. You have got totally 11 observations and you find that you have been asked the median time is 1.8, you find that 1.8 is equal. So, this observation, as I have discussed earlier, has to be left out. So, totally you will be having in your hand 10 observations. So, that is left out. So, you continue with the remaining 10 elements. Now you have to find out the sign sequence S1, S2, etc. up to S10. So the sign sequence is of this form, that is, go to the problem, median value is 1.8. So when you take the first observation 1.5, you take the difference, it is 1.5 is lesser than 1.8, so it becomes negative. Then 2.2 greater, so you compare the values. So as you compare the values, you will have minus, plus, minus. So all the values which are greater, you give it as plus sign, lesser values you give out the minus values. So here you count the minus values. So here you have got 1, 2, 3, 4, 5, 6 and 7. So the realized number of minus sign is y is equal to 7. So the number of minus sign y has now the binomial distribution, namely with parameter n and p, since your h naught is true. So here what is your h naught? H naught is such that median value is equal to 1.8. So you want to find out S. S is nothing but number of signs which are greater than 7. Using binomial distribution, you know that probability of x for binomial distribution is NCX p power x q to the power of n minus x. You want to find out the value of s greater than or equal to 7. So x is equal to 7 to 10. So n is 10 Cx, and here your p value is 0.5. So q is 1 minus p. So 1 minus 0.5, 10 power x. Look at the table. Summation is valued from x is equal to 7 to 10. So the values are for x is nothing but 7, 8, 9 and 10. So I have split and brought in the form of a table. So here when x is equal to 7, 8, 9 and 10, what is my probability? That is 10 Cx I have found out for 7, 45, 10 and 1. Next column is that I have to find out, that is my p of x is NCx p power x q to the power of n minus x. So here I have found out next my p power x. So p power x is 0.5 to the power of x. X takes all these values, is this column. Next column is nothing but q to the power of n minus x. So here n is equal to 10, give values for x. So you will have 1 minus 0.5 is 0.5, raise the power of 10 minus x is equal to 10. So you will get it as totally n is 10 observations. So 10 minus x is 10, 0, anything raised the power of 0 is 1. So similarly substituting, you will get the values. So you find out the probability, that is you multiply all the 3 columns, you will get the required probability values. So the total probability is this. Now your hypothesis is nothing but you want to check whether that number of hours is 1.8 hours against the alternative not equal to 1.8. Therefore it is a two-tailed test. Hence the total probability value multiplied by 2 will give you 0.34375. Here we have found out the probability value, and you compare with your critical value alpha at 5% level. You find that 0.34 is greater than 0.05. So here remember that you are comparing the probability value, hence p value, the required condition is that if the calculated value is greater than 0.05, you do not reject the hypothesis at alpha is equal to 5%. Therefore the conclusion is that there is no evidence for a median not equal to 1.8 hours. Next we will go to example 2. This is for a 2 sample test. So 16 drivers tested 2 different types of tires R and B. the gasoline consumptions in kilometers per liter were measured for each car, and the results were, it is given in the form of the table, where totally starting from 1 you have got 16 observations. R value, that is tire R, tire S is given, the values are given for 16 observations. So here you are also given the sign values. So sign sequence calculated from the difference of consumption is given as, you can check these consumptions also, namely that 4.2 and 4.1, if you take the difference, it is going to be positive difference. Here if you take, it is a negative difference. See here, positive and negative. So sign difference is given, and at one particular point you find that namely that at two states you will have the values are same, namely that 5.7 and 5.7, if you take subtract, you will get it as 0, and at one more juncture, namely that here when you take the difference, this is equal to 0. Therefore at two states the values are same, so it is 0. So here the population consists, also you are given that the population consists of the difference of gasoline consumption, that is, this is the difference. The null hypothesis is that the median of the difference of the consumption is 0. So here you want to test H naught such that eta is equal to 0 against the not equal to 0 or greater than 0 or less than 0, whatever is your alternative, you have to test at 5% level. So here coming to the solution, in two cases the results were equal. So here totally 16 observations are there. I have shown that two observations are equal to 0, so your size reduces to 14, and the realized number of minus sign is, here it is 1, 2 and 3. So here y is equal to 3. So the population consists of difference of gasoline consumption, hence the hypothesis you are going to test is going to be H naught such that eta is equal to 0 against the alternative I have taken eta is greater than 0, median value is greater than 0. So here three values are, you find that the number of minus sign is 3. So I want to find out probability of x is less than or equal to 3. So here I is equal to 0 to 3 using the same binomial distribution NCX p power x q to the power of n minus x. So n is 14, and in the place of x you have got I ranges from 0 to 3. For binomial distribution I have said that here in this case it is equal, differences are equal, so p is equal to 0.5 and q is nothing but 1 minus p. So calculating the probability values, finally you land up with probability x is less than or equal to 3 is going to be 0.0287. How to work out this I have given in the example 1. So here come to this particular thing, probability that x is less than or equal to 3, you have 0.028. This 0.0287, you find that this is less than 0.05. So here remember that you are calculating the, comparing the probability value, hence p value, under p value the null hypothesis has to be rejected. As earlier I have discussed in the procedure, saying that if the calculated value is lesser than the table value, hypothesis is rejected, otherwise it is accepted. And hence we conclude that when considering the median of the differences of the consumption, the tire R is better. So next we will go to the next concept. For that let us define the concept of run. So what does that concept says that, suppose if you have n1 observations of the random variable x and n2 observations of the random variable y, and suppose we combine the two sets of independent observations into one larger collections of n1 plus n2 observations, and then arrange the observations in increasing order of magnitude will give you the run. So here if we label from which the set of each ordered observations originally came, we might observe something like that. Say for example, if original observations you have got for x, you have got some particular value, y you have got particular value. So here you will have sample 1, sample size will be n2. So combine these n1 and n2, arrange them in particular order. When you arrange it, you will have this, combine all the x, y, y terms. So here I have shown one particular model. So where x denotes an observation of the random variable x, y denotes the observation of the random variable y. The number of elements in a run is usually referred to the length of the run. In one, length of the run is 6. So I said that you take the observations of x, say observations of x, x1, x2, etc., or x you write, y you write it as y, etc. Say n1 is equal to 2 or 3, or y you take n2 is equal to 5. Arrange them, put together, arrange it in a increasing order. I said you will land up like this, and here you combine, put a parenthesis for the equal symbols. You find that the length of the run is, here it is 1, here it is 2, 3, 4, 5, 6. So here you paired into 6 types. So the length of the run is going to be 6. So here now we will go to the main part of the problem, that is the Wahl-Wolff's run test. Now you are familiar with the run test. What is the Wahl-Wolff's run test says? This test is used to examine whether the two random samples come from the populations having the same distribution. This test can detect differences in averages or spread or any other important aspect between the two populations. Next, this test is efficient when each sample size is moderately large. Usually we say that greater than or equal to 10. If the sample size is greater than or equal to 10, we call it as a large sample. So here we define the hypothesis H0 such that two samples come from the populations have the same distribution. H1, two samples come from the population having a different distributions. So what is the test statistics? So let R denote the number of runs. So I have taught you how to find out the number of runs. To obtain R, list the, that is this is the procedure for R. To obtain R, list n1 plus n2 observations from two samples in the order of magnitude. Denote the observations of one sample by x and the other samples by y. That is some sort of symbol. Count the number of runs. Critical value, difference in the location results in few runs, and difference in spread also results in few number of runs. Consequently, critical region for this test is always one-sided. Critical values, though you are considering two sets, it is going to be one-sided only. The critical value to decide whether or not the number of runs are few is obtained from the table. The table gives you the critical value, which I am denoting it as RC for n1, size of the sample 1, and n2, the size of the sample 2 at 5% level of significance. Decision rule is that if the calculated value is less than or equal to the table value, that is your critical value, reject H0, otherwise you accept. So in this particular situation you will happen to get a tie situation. So in case x and y observations have the same value, place the observation of x in sign test. If the observations have the same value, you subtract it and you put it as 0, and you try to neglect that for the remaining observations only you have taken. But here in your run test you cannot do like that. Here you have to place observations of x first. If the run of x, say for example x is written as first, then the values seems to be x and y have the same value. If you have placed x first, next you have to place only x. So that is what I have said, place the observation of x first if the run of x observation is continuing, or y first if the run of the observation y is continuing. So large sample, if sample size is large. So here in sign test sample size is large provided if n is greater than 10. If here we take sample size to be larger if it is greater than 20. Critical value of RC, how to find out, is given by RC is equal to mu minus 1.96 sigma at 5% level of significance. Now how to find out mu? Mu can be found out using this formula, that is 2n1 n2 divided by n1 plus n2 plus 1, where n1 is the size of the first sample, n2 is the size of the second sample. Then you can find out sigma squared using this particular formula. So getting the values of mu and sigma, substitute here, you will get your RC value, compare it and draw the inferences. So in today's class we have discussed about the non-parametric test. So here I have said that parametric test keeps the normality conditions, whereas in non-parametric test it does not make any assumptions regarding the form of the population and there is no normality conditions. So we have discussed two types in the sense that two methods of non-parametric test, namely sign test and Wald-Wolf's run test. In sign test you arrange given sample, you fix the median or the mean value, compare it with the given observations and mark plus or minus sign, and if the observations are same put it as 0 and from the total sample neglect the number of zeros, then looking into the number of minus sign. Depending upon the number of minus sign you fix your probability using the probability distribution, get the value, compare with the p value, that p is equal to 0.05, draw the inferences. If the calculated value is lesser you try to reject, if it is greater you try to accept. Now when in Wald-Wolf's run test, before going to Wald-Wolf's run test, if the case is for two sample sign test, you take the difference. After taking the difference you try to do the same procedure what we have done for the one sample test. In Wald-Wolf's run test, here the samples have to be drawn from the same population or from the population with the same density function. I said that you pick up the samples from the first set, pick up the samples from the second set, try to combine it, arrange it in the order of magnitude. After arranging the number of magnitude you try to collect all the x and y values and you mark it out, check the length of the sequence, that is you will get your run. How many runs are there? Depending upon the runs you proceed and check whether your sample size is larger. If its sample size is larger, I have discussed that how to find out your critical value. So get the critical value, compare it and draw the inferences. So this is going to be your Wald-Wolf's run test. And some more types is there which we are going to discuss in the next class. So now I have got few questions for you to answer. Point out the difference between the parametric and non-parametric test. Second, point out any two advantages and disadvantages of non-parametric test. Explain the sign test. Here you need to explain what is one sample sign test and two sample sign test. explain Walls-Wolf run test in a detailed manner. Thank you.